Hello, everyone. Here are your notes for circumference, which is section 2.3. So you're going to look for circumference on ingenuity. Okay, so first of all, we're going to talk about something that's not a circle. This guy is called, it has 1, 2, 3, 4, 5. It's called a pentagon. So it's talking about walking around a polygon. Tanya likes to take walks around the pentagonal garden at her local park. The garden on the left has how many sides? 1, 2, 3, 4, 5. We call them congruent. So in geometry, we put tick marks sometimes to show that all those sides are congruent. So that's something new that you might want to start doing. If she starts at one vertex or one corner and she goes all the way around, how far will she go? Well, you can do this by addition. You can take 2.5, now she's this far, and add another 2.5. Now she's this far and keep going. Or some of you might have right away have seen that there is a quicker way to do that. We could have just taken 2.5 times the number of sides, which is 5. You'll go to your calculator probably, and you'll get 12.5 meters. This is called perimeter. When you walk around the outside of a figure, that's called perimeter. Sometimes people think about the rim of a basketball hoop or the rim of a glass and remind themselves that would be the outside of the shape. So we're going to talk about a circle now. We're going to kind of talk about the perimeter of a circle, but we don't call it a perimeter. And that's what we're talking about today. But first, let's talk a little bit about what makes up a circle. So a circle is all these points that are equidistant, the same distance from a center. So I think maybe all of you have done this before. If I put a nail here and a string on the nail, and I put my marker on the edge, I can flip it all the way around. And as long as the string is very, very tight, it would be a perfect circle. We used to do that with the jump rope when I was young. Somebody would stand at the middle and we'd put sidewalk chalk and we would make circles on our sidewalk. If you just have this distance from where the center would be to where you start drawing, it's called the radius. Now, if you stretch the radius out again, so that the radius is over here too, and you put them together and you go all the way across, that's called a diameter. Okay, a lot of times they use the letter R for radius and the letter D for diameter. And you can see that if you take a radius plus a radius, that's going to equal the full diameter. So sometimes we say that 2 radii equal 1 diameter. Okay, so it has to go through the center, and it's a diameter, and it has to be half of a diameter. Another thing we could say is half of a diameter is a radius, or you could say the diameter divided by 2 is the radius. And we're going to practice a little bit with diameters and radii here. First, we're going to see if we can find them all. So we're looking for the radii, which is, if you remember, you have that circle. We're looking for just center to the end. So let's look what we have here. Is A to B a radius? You bet. How about C to E? No, C to E is going all the way across. That's actually what we call a diameter. So that's not what we're looking for. We're looking for a radius. How about A to C? Yep, that's a radius. F to D. Now look, this one doesn't even go through the center. F to D, we're not going to talk about for a long time, but that's actually called a secant. And then you have A to E, and that is also a radius. So the radius are the ones that have start at the center, end up on a side. What about this guy up here? Does anybody know what that's called? We'll learn about that probably later this year too, and that's actually called a tangent. Okay? You don't need to know that, just some extra stuff in case you want to be super smart. So we're going to, like I said, walk around a circle. And when we walk around a circle, it's hard to measure. We can't really measure with a straight ruler. You could measure if you had one of those flexi tapes and you could go all the way around. So what we can do is we can measure straight across. That can be measured with a ruler. So we have these formulas that we can use, and it allows us to calculate how much you would walk, or like the perimeter of a circle. And we call that circumference. Circumference is the length around a circle. Okay, so it's like perimeter. A lot of kids think of it like perimeter. You can measure it with a flexi tape, but not a straight ruler. So the unit will be just like centimeters or inches. They're not squared. We're not talking about area today. We're just talking about a length. So since we can measure straight across, the first formula is circumference is pi times diameter. Now, pi is a button on your calculator. It has lots and lots of digits. Sometimes we use just 3.14. Your calculator knows all the digits. Sometimes Edgenuity is going to tell us to use this fraction, 22 over 7, to approximate it. Sometimes it might tell us to use 3.14. Okay, so if you're not getting the exact answer as the multiple choice, make sure we're using the right thing they want us to. You can use your notes on tests and quizzes in here, but when I was teaching this before I allowed kids to use notes, I used to remember that circumference equals pi times diameter. It looks like a table and a chair, kind of. I don't know if you can see it. Another thing you can say is cherry pie is delicious. Or I guess that's it. Those are the only two things I have. So here's an example. For this circumference, we're going to use the formula, which is pi times diameter, and we have a diameter and it's 12. So that's pi times 12. Now we usually put the number first. So if we're going to give an exact answer, we say 12 pi centimeters. This is what we call an exact answer. If we want exact, we don't change the pi to anything. If you want it in decimal and you take 12 times 3.14 in your calculator, you might say that that's 37.68 centimeters. That would be a decimal approximation. We'll see what your math lab wants you to do, not your math lab, your Edgenuity wants you to do. So just be patient if you can't quite figure it out or ask one of us. Okay, another formula you can use is because the diameter is related to the radius. Remember how we said one radii plus another one is the whole diameter? We can change the diameter to 2 times r and have another formula. So if they tell you the radius, we can use 2 pi r. And it might make more sense if you're like, why don't we just say pi times 2r, because that's how this was, pi times diameter. For some reason, we like to put the numbers in front of formulas and the symbols after, but it really doesn't matter. There was a song you could sing, twinkle, twinkle, little star, circumference equals 2 pi r. So you could do that to help you remember, but you can just use your notes and have it memorized that way. So in this problem, they tell me what the radius is. So I'm going to do 2 times pi times the radius, which is 5.5. Now, if they want an exact number, you just take the 2 times the 5.5, which is 11, and you would just say 11 pi centimeters. If they want an approximation, you'll take 2 times the 3.14 or the 22 over 7, whatever they're going to tell us to do, times 5.5, and you'll type it all in your calculator, and you'll get 34.54 centimeters. Okay, so that's a little bit of practice with the formulas. We're going to practice a little more here. This one has the diameter, so we're going to use the formula circumference is pi times diameter. They want an exact one. The diameter is 14, so my answer would be pi times 14, which we can rearrange to make 14 pi. Here's one with the radius. Okay, so what is true? Would the diameter be 30.8? If the radius is 15.4, I can draw another radius here, which is 15.4. And sure enough, if you take 15.4 times 2 or add it twice, you do get 30.8. That is true. What would the circumference be? Would that be 30.8 pi? Well, if you use pi times diameter, since we just found out the diameter, that would be 30.8 pi meters. That's true. My pi was really bad looking there. Could I use this one? This was using 2 times pi times r. That will be the same thing. We can use that as well. If they wanted us to approximate it, and I used pi, could I plug 30.8 times pi, or 3.14 in my calculator? Let's see what I get. 30.8 times 3.14. My calculator tells me that's 96.712. They want the nearest tenth. Is that the nearest tenth? Would be right here. Is it 96.7? You bet. And is that a little more than 6 diameters can be wrapped around it? Well, let's think about that. How many diameters could be wrapped around it? The diameter is 30.8. If I take 96.7 and divide it by 30.8, I get about 3.14 times, not 6 times, about 3.14. So that's not true. And the reason this works, guys, because if you take the circumference and you divide it by the diameter, you can get pi, or 3.14, and that's actually where it comes from. Okay, how can you find the diameter if they tell me what the circumference is? Well, if they tell me the circumference, I'm going to write down my formula, which is circumference is pi times diameter. They told me the circumference. The circumference is 55 pi, but I also know that equals pi times diameter. So what we can do is we want to get diameter by itself. You can divide both sides by pi. Those pi's will cancel, and you can see that that diameter is going to be 55 feet. Okay, let's see what this student did. They were solving for the radius, and they told them the circumference was 12 pi. So the first thing they did was they wrote down their formula. That looks good. And they said 12 pi is 2 pi r. So they're trying to get the radius by itself, so they divided both sides by 2 pi. They got 6 here because those pi's canceled, and 12 divided by 2 is 6, but look what they did here. They got the 2's, but look what they forgot to get rid of. They forgot to get rid of the pi's. Really, the radius would just be 6. They forgot to simplify this, so they did the pi twice. So the students made the mistake in step 4. But what they should have got with the radius was being 6 centimeters. They did extra work. Nobody wants to do extra work. So let's go to this next one. On a hike, a family discovers a huge tree. They want to know what the diameter is because you can't very well measure across the center of a tree. But they had their flexi tape and they went around it and they got that the circumference was 94.2. So we can find the diameter by doing pi times diameter. The circumference was 94.2, and that equals pi times the diameter. Now remember, pi is just a number. It's like 3.14. So you can divide both sides by pi, or 3.14, and type 94.2 divided by 3.14, or by the pi button, and the diameter is about 30 inches. I got that from typing it in my calculator. Okay, the circumference of a clock, you can go all the way around this clock, and it's 44 inches. Find the length of the minute hand. Well, which one is the minute hand? That's the same thing as a radius. This time they want us to use 22 over 7. So they told me the circumference. And because I'm looking for a radius, I'm going to use the formula 2 times pi times r. But they want me to use 22 over 7 instead. So 2 times 22 over 7 times r. They told me what the circumference is. The circumference is actually, can I erase here? 44. So I have to figure out what r is. Well, let's go ahead and take these two numbers times themselves. 44 equals, well, what is 2 times 22 divided by 7? That gives me a really big decimal, okay? So that gives me 6.28, we'll say 57. And then times r. If you divide both sides by 6.2857, you can figure out what the r is. 44 divided by 6.2857, and I get it's about 7 inches. I bet if I used the real pi, it would be exactly 7 inches. Okay, we're going to find the distance of this track, and this is kind of tricky. So definitely this is 100. What's this going to be down here? 100. I don't walk a track like this. I walk around the edge. So I don't need the 42. What I need is the circle length. Well, if you put those two edges together, you get a full circle, and the diameter, which goes all the way across, is 42. So the circumference is pi times the diameter. So if I take pi times 42, that's going to give me the whole circle. So I'm going to take 3.14 times 42, and I get 131.88. That's for the whole circle. If you wanted to do half of that, each half is going to be 65.94. But you could just use the whole thing if you want. So what is the whole track? Well, I'm going to take 100 plus 65.94 plus 100 plus 65.94. Or you could take 165.94 times 2 if you wanted, and I'm getting 331.88 meters. So sometimes they'll want to cut a circle in half, and you can do the circumference and then just divide it by 2. Okay, let's try this last problem. Helen is putting a fence around her flower garden. There's this half circle here. It doesn't look like a half circle, but it is. If the semicircle has a diameter of 7, how much fencing is she going to need? So she needs this here. So she needs 10 plus 7 plus 10. So that's 27. She needs 27 for sure. And that's the 3 sides of the rectangular. Then she needs half of the circle. Okay, so we're going to do pi times diameter because they told me the diameter, or pi times 7. But that would be a full circle, and that's 21.98. I only need half a circle, so I'm going to divide that by 2, and I'm going to get 10.99 for half the circle. Oh, they didn't want me to use 3.14. That was my fault. They wanted me to use 22 over 7. So I'm going to take 7 times 22 divided by 7, and I get 22. That's better. Take 22 divided by 2, and I get 11. So this is what I should have put here, is 11. Now we can find the total fence. Take 27 plus 11, and we get 38 feet. Okay, be careful. I accidentally used 3.14, and they told me what to use. So just pay attention to what they need you to use. Okay, good luck on perimeter today.